In our previous videos, we discussed about what REST is and what is a service-based architecture. Now we'll step into the world of microservices and understand service-oriented architecture or the service-based architecture in a whole new level. Before getting into the detail, let's understand what a service is. Service is like an offering that is provided by some service provider. For example, a customer care service. We as laymen, we know that for everything we have some customer care service. For example, for our phone network, we know a customer care service exists and we know how to reach them. That is by dialing a number, say 131313. By calling them, we can place our request and they will service you. That's simple in a layman world. So is what is happening in the applications world as well. There are a lot of service providers who are providing various operational and logical support by hosting services all over the world. And the websites or the front-end application can connect to these service providers and get their job done. Similarly, in the application world, there are a lot of services that are provided by various service providers. For example, we have a functionality or a facility to pay bills online. What do? You just open the website, you punch in your details and log in into it, and then you look at the bill for this month and click on the button Pay. That's it. Your bill is paid. How does this happen? What is happening behind the scenes? How did the money get transferred? All this is done through services. The next key element for fulfilling a service-based architecture is REST. REST is the technology that enables or powers a service-based architecture. The full form of REST is Representational State Transfer. The name is pretty complex, but let's not go there. It is simply an endpoint, just the way you had a number 131313 to reach the customer care service. REST is like a hook or a URL that is hosted somewhere in the world which you can reach by just punching in the URL, which is called the endpoint. So just the way you paid your bill when you clicked on Pay, behind the scenes what's happening is that your website is making a call to the endpoint http://gasproviders.com/bill/pay, and your credentials and your details and the pay amount is sent to the service provider. Behind the scenes, the service providers takes care of paying the bill for you. This is enabled by the technology called REST. Let's look at the olden day architecture. In olden days, for example, we are considering an e-commerce website. It can be eBay or Amazon. What do you think are the various features that is supported by an e-commerce website? You know that you can see the stocks, what they are selling over there. You can place orders. You can have your shopping cart. You can have your wish list. You can pay bills. You can cancel it. You can refund it. So all these are various functionalities or features that's offered by the e-commerce website. In olden day architecture, all of this logic, all these functionalities, everything was written into one single backend service, and the code was pretty monolithic. Monolithic means everything was just dumped into one place. So when a new programmer comes to the team or joins the team, if he needs to understand what's happening, he needs to have a picture of the entire backend service application. He needs to understand all the features because it's written as one intertwined spaghetti code. The most scary part for this is that the whole backend service relies on one single chunky database where all the data related to inventory, payment, orders, invoices, everything is residing in one single database. From the olden day monolithic architecture, we moved on to something called service-based architecture. In service-based architecture, all of the code still lives together on the same server, but what was the beauty of this is that we segregated the various features and functionality of an application into modules, which is called as the services. And each of these services started exposing their functionality through endpoints, which is also called as REST endpoints. In this backend application, if you see, we have broken down the whole system into 4 submodules, which is the inventory, orders, purchase, and payments. Now, if the e-commerce website in our example, if they want to make an order from a customer, all they need to do is make a call to the orders module. If they want to get the list of inventory in their store, they make a call to the inventory module. If they want to have a purchase order, they go to the purchase module, and if they want to make a payment, they go to the payments module. This way, there's a clear demarcation of which module is doing what. And all these individual modules is exposing their services through one or more endpoints. In this example, to keep it simple, I have just shown one endpoint, but it can be one or more. But what is the disadvantage of this particular architecture? It is pretty much the same as the disadvantage we had for the monolithic architecture. That is a single point of failure. If for some reason the server crashes, the server where it is hosted crashes, or there is some technical glitch, the whole application goes down. When the whole backend service goes down, that would mean none of the modules, be it inventory, orders, purchase, or payment, would function. That means technically the e-commerce website is down and the customers can do nothing with this website, which is a major business loss. One of the ways to solve this problem is to have high availability setup. That is, replicate the whole system in another environment such that even if one of the servers crashes, automatically the traffic starts flowing into the replicated environment. This is one of the solutions for sure, but not the best one. We can do better. That is where microservices came into picture. Now, how different is a microservice architecture from a simple service-based architecture? Let's draw a parallel between the two architecture methodologies. So, in our previous example, yes, we had a backend service which had various endpoints which is categorized into modules. But now, instead of maintaining all those modules in one backend service, we break them into 4 separate, individual, self-sufficient modules which are running independently on independent instances. That would mean either they are running on their own instances within the same server, or they are living on different servers, or they are scattered between servers or cloud environment. Doesn't matter. They are independent. Also, instead of depending on one chunky or a bulky database like in the previous architecture, these modules are now relying on their own tiny, dedicated databases as well. This way, each module is self-sufficient in themselves. They are less likely to be dependent or affected by the other modules. Let's take an example here. In such a setup, if suppose the inventory module goes down, for some reason the server crashed, technical glitch, DB is not connecting, whatever. But still, the customers can continue to place their orders and they can continue to make payments for their orders. The business is still going on. And the operations of the support team can very easily pitch in, and they just need to investigate on what went wrong in the inventory module rather than looking through the entire monolithic application to understand where the bug could be. Here for sure, the bug or the issue is in this particular instance, and the other instances keep running untouched and unharmed. The second benefit of a microservice architecture is that each module can be built on diverse platforms and hosted on different environments. In the previous architecture style, all these modules had to be in one particular language or a platform because, of course, it's one single application. It's either Java or either .NET or either Python or any of the other platforms for that matter. But in this style, it is possible that the inventory module is written in Java, the orders module is written in .NET, the purchase module is written in Python, and the payment is also written in Java. So there is a cross-platform survival over here. If tomorrow there is another new module that comes in and it's written in a completely different language, it doesn't matter. It is easy to spin up its own instance to which the website can talk to through a common language called JSON. So all these individual modules, irrespective of the platforms they are written in or irrespective of the environments they are hosted in, they can still coexist. The third advantage of a microservice is easier to maintain, support, and deploy. Let's say there is an upgrade. There's a new feature that needs to be added to the purchase module. The DevOps people or the support team would need to bring down the purchase module, give the fix, make a new deployment, do some regression testing just on purchase module, and bring it back up for the website to access. So when this purchase module was down and some setting changes were happening, the inventory module, orders module, and the payment module was still up and running. And usually after any deployment, we need to do a round of sanity check to make sure that the applications are still running fine. In this case, the effort required to do the sanity check is just minute because we just need to focus on the purchase module as that's the place where we disturb. Now, what could be disadvantage of such a lovely architecture? In simple terms, it is complex. Microservice is not meant for all organizations or all applications. You should adopt microservices only when it is required to. In our previous example, we saw there were 4 modules. If the 4 modules are very chatty among each other, that would mean that that's really not microservices because those modules are interdependent on each other so much that they should actually be put into one particular module because they're chatty. Microservices should be designed very carefully, otherwise it can prove to be very expensive to the organization or to the project team. So we need to have a really good experienced architect to design a microservices application. Not every organization or application needs microservices. That's exactly what I said. We need not complicate or use microservices just because it's trending now. Analyze whether your application needs it or not, and only if it is absolutely required, adopt it, because otherwise maintaining can be a challenge. Finally, since it's microservices and there'll be a lot of communication and traffic flows and transactions happening between the modules, the whole expense of the project can go really high. So again, evaluate the need of microservices within your application before you adopt it, because it's not just an application change, but it's actually an organizational cultural change as well. For more such videos, keep following and subscribing our channel. See you in the next video. Bye for now.